Hi, so recently we published a detailed Medium article titled Building Webhooks That Never Fail. If you haven't read it, I highly recommend it. It walks through the architectural decisions that helped us reduce webhook loss to near zero. Today we will quickly understand what was wrong with our earlier system, what we changed, and then I will walk you through a live working demonstration of the full system. We have also open sourced this reference implementation. You will find the complete codebase link in the description. Earlier, our webhook flow looked like this. Payment succeeds, we update the Postgres, we spawn an async task, we send webhook, retry if it fails. Simple, clean, worked most of the time. But here's where it failed. Deployment rollout, pod restart, out of memory crash, network timeout during shutdown. Here's the new architecture flow. The shift was simple in principle. Webhook delivery should be derived from durable state. We now do payment return to Postgres, database triggers a create a domain event, Sequin reads from write ahead log, it publishes to Kafka, Restate consumes from the Kafka, Restate runs durable workflow, and Svix finally delivers our webhook. So now if the service crashes, the event already exists somewhere durable. Now let's map that to actual code base you are seeing. And before proceeding further, I would like to tell you in this demo repository, we stimulate production using 3 core services. The service one, our new API service, this is the payment entry point. It accepts post payment, writes payment to Postgres, and triggers a domain event. Our second service is a data service. This service is responsible for payload enrichment. When a webhook is about to send, Svix caller calls the data service. Data service fetches the latest payment state and returns the enriched payload. Why? Because delivery might be delayed. We want current state, not stale snapshots. Our third service is the Svix caller. This is durable webhook processor. It consumes Kafka event, run inside Restate, fetches data from data service, sends event to Svix. So the separation looks like this. New API writes the truth, data service reads the truth, and Svix caller delivers the truth. Okay, so I've cloned the repository. You can find the GitHub link for the same in the description. Let me open it in the VS Code. In the VS Code, if you will go to the local setup.md, you will find the exact steps to clone it locally. So we are using Docker. So first we will set up all these services so we can use Docker Compose up. This would take some time. It would build all our 3 services along with the infrastructure needed. Okay, so finally it took some time, but it has built all the services. So we can now proceed with the demo. So now since we are done with this step, also note I have already obtained the Svix auth token. You can go to the Svix website and get the API access token and add to the .env. So now we will set up our Sequin. Right, so for that we will go to the Sequin setup.md. Again, all the code is already been uploaded to the GitHub. So first make sure to run this command because sometimes it doesn't create. So let me split the terminal into 2 halves. Okay, so it created this Sequin slot. Now we will navigate to the localhost 7376 to set up our Sequin. In the Sequin, what we will do is connect to our Postgres database and also configure Kafka to where we will publish it, right? So let's go to localhost 7376. Welcome to Sequin. Get started. Perfect. Now we will connect our database. Again, all the credentials and all are being uploaded to the README. So our database has been finally connected. Now we will connect our sync, and for the sync we are using Kafka. So create sync Kafka, right? Before doing so, we will also need to create a function, create a new function. We will configure this function because we don't want every data. We need the exact database record from sequence metadata wrapper. Now we will create function. So our function has been created successfully. Now if we will go to the sync, create a sync, add Kafka, and enter the details. Again, I can switch it to the preview mode and enter it fast. Create sync. If you want to ignore this warning, you can run this command too. The warning has been removed. Now we will register our restate. So we can use this script. So the restate has been finally connected to the Kafka. Now I will use this merchant ID that I have created before. We can create a new one too. So what we will do is go to our Sequin, right? Add application. We will name it demo app, right? Now we can copy this command and run it here. The bearer we will use from what we got from the .env. Paste it here, enter. You can see the demo app has been created, right? But since in the database we are using a dummy seed ID, so for now I will use this merchant ID only. You can create a new one and get the ID as I have shown in the demo, right? So I will use this merchant ID only. So now let's create the test payment and test it. So it shows succeeded. So let's also verify from the dashboard. So if I go to this merchant ID, you can see per payment succeeded. And if I reload it, you can see for this is for the 25 February, right? So today is 25 Feb only. So this came for the payment succeeded one. Now this shows that full setup is working, right? We can also verify with the Docker Compose logs to verify that everything is working successfully from the logs. So now we will run the test script for the test. Let me give a quick demonstration. So what in the test is being done is, so the test script would basically test our old architecture where Webhook was in memory, right? And the new architecture where we are using Kafka, right? We are using Sequin, we are using Svix and also Restate. So let's run the crash script. You can see the logs are running quickly. Now the old API has been exited. You can read the full test script to get the full analysis of what the test script is doing. So in the old architecture, we lost 8 webhooks when the pod was destroyed. Right now we will do the same thing, but in the new architecture crash test. We would first run some 100 payments. We will kill the pod that is a Docker container, and then we will rerun it. But this time all the 100 payments would be succeeded because we are using restate. So none of the webhook are missed. Now if I go to Svix dashboard also, currently we can see 25 February only one payment, right? So the 100 are created, so we need approx 100 payments. Let me refresh it. Cool. So 20 items for 20 Feb and 80 and 20 100, right? And our last 101 that was created during the initial steps. So this is the main thing that I want to demonstrate, that in the old architecture, if the Docker container or the pod was crashed, the webhook delivered it at that point of time were all lost. But when we implemented the new architecture with proper retry mechanism, we obtained a 100% delivery rate despite the pod was crashed in the new architecture too.